live, I guess. Let me check. Streaming. Alrighty. So let's get back to whenever we finished last time. I'm trying to put my mic levels a little bit up, trying to put the music down. We'll see how it does. Alrighty, so let's do this. Just doing some stuff off camera. I just wanna plan for today is like quickly implement it on camera so you guys know what I'm doing. The main gist is gonna be creating a geometry class so we don't have all this hard-coded vertices bullshit, and also so we can reuse them, and so the message doesn't even need the context or actually creating buffers and all this bullshit. So first things first, let's just create a new file, EB03.js. Alrighty, and I got this one right here. Class, export it. Open our constructor, and here we're gonna be receiving, of course, our context. So I wanted to create buffers and shit. We're gonna receive our position, of course. And since I'm already doing like a whole geometry class, let's start also putting like some indices or an index, so we can do like draw elements instead of draw arrays, and not repeating, redeclaring vertices that repeat. Of course, since we're already gonna have multiple attributes, it's gonna also have some optional normal colors and UVs. That's gonna be pretty much our standard geometry right there. So first thing first, so we can completely unlink the geometries from the shaders. The only thing that's stopping it right now is that we actually need to get this attribute location. Right now we're just doing it like with GL get attrib location and the string, and we're catching it because this takes some time to do, but I was doing some research and I see that on version 300 DS of OpenGL you can get this puppy. Just like this layout thingy. Search for it. So layout. There you go. So when you are gonna do like any kind of input or output, you can use this layout thingy to actually declare the actual index that you want on the location, and that way it will be a known index and you will not need to actually do the lookup like we're doing right now with this get attrib location. So that's what we're first gonna be doing. Own our shader, so that shouldn't affect our current code. And like I said, it's doing like layout, then location equals to whatever index we want. In this case, it's gonna be 0. So right now we know all our shaders pretty much are gonna receive always their position attribute on the location index number 0. So this way we can just like create a constant on this class. Let's call it like attributes, and it's gonna be like a key map, key value object with the actual key and the index of our uniform location. So this is gonna be 0. It's just define, even though we don't have it on node shader right now, but for good measure, let's just define already the rest of locations for normal, color, and UVs. 1, 2, 3. Good. Let me put down this a little bit down. Cool. Okay, so let's keep going. Now, what we need to do is pretty much whatever we did right now on the mesh, which is creating the vertex buffer and basically passing the data of our position. So for that, what we're gonna do, and also of course what we want to start implementing now we have our locations known, we're gonna be doing all the things that we did on our render routine, all these vertexAttribPointer assignments, and store them on a vertex array object. The same is gonna be for the call of the enable. This one will also be outside of here and part of your geometry. So let's start. First we're gonna get our attribute list from the geometry class. We're gonna first create our vertex array object for the geometry, and of course we're gonna be binding it. WebGL binds vertex array, and that's gonna be our VAO. And once we're done, we're just gonna unbind it, binding it to null. And here is whatever we do here. Instead of, when it comes to bind buffers and setting attributes and all that, will be stored on this vertex array object. And since now we're gonna have like multiple vertex buffer objects instead of just being one like it was before on the mesh. And right here, what we're gonna be doing is an actual array, so we can have them all. So then we can actually dispose this properly, this geometry. And I'll write this later. Let's go with this. And since we're gonna have a bunch of buffers that pretty much do the same, we're just gonna implement a quick function that I got it right here. I'm just gonna copy and paste it. And this will be a handler to create and buy all of our vertex buffer arrays. As before, it just creates the buffer, it binds it to GL array buffer, sets is whatever data we pass to with a buffer data on your static draw on the first offset, and then it will enable the vertex attribute array for the actual attribute, which I just realized this is wrong. It's going to be data and attribute, there you go, size and type. Cool. So it will just actually, as you pass position, it will enable the attribute 0, and the same thing goes for the vertexAttribPointer. and it will just do that. Like we select that location with whatever size we pass, and the type, which will default to GL float, because like 99% of our attributes are gonna be floats, and I think most of them are not gonna be normalized. I think that's that one. No, let me see. It's not gonna be normalized. It's false, and their stride, because it's gonna be single buffers, no interleaved shit. So it's just gonna have a stride of 0 and start on the 0 also, like an offset of 0. And finally, it's just gonna push our buffer to our VBO array, and since we're gonna be running all of this while our vertex array is binded, it will also be attached to them. So finally, what we just need to do is to call this function first, and pass it our position, right? And of course, we need to, since we're gonna receiving normal arrays here, we're just gonna pass it to through a 32 array. I'm gonna set the attribute to position. The size is gonna be 3. And the type is gonna be default GL float. Now next thing, for the normals, it's gonna be the same. Normal. And it's gonna have a size of 3. Also float. Color is pretty much the same deal. And finally our UVs are gonna be floated to 2 arrays, but on UV I'm gonna be a size of 2. This is just X and Y or S and T, depending on what API you're using, but just 2 values for the UVs. Okay, so finally we just need our index, and we're pretty much gonna be doing that index optional. So we support also just drawing plain arrays. So if we are not getting our index, we're just gonna store the count that we used to do before on the mesh, like this. So we can then call draw arrays with the count if we got no index. So this count is gonna be pretty much equals to our position buffer, which is that one, divided by 3. Cool. And finally, if we got an index, then we should create an element buffer object, which is gonna be pretty much another GL buffer. And of course we just bind it. I'm gonna do, what is this? Element array buffer, right? Yes. And we're just gonna bind our EBO here. Cool. Let me just copy this ones. Like any other buffer, we're just gonna, with a buffer data, but to the index we bind it, we're just gonna get, and for now we're gonna use uint16 for our index, because this gives us to 75,000 indexes or something like that. But if sometimes we want to have like huge messes, we probably will go with 32, but I guess uint16 should be plenty for our indexes. And finally we're just gonna store it on a variable, so we can then on our dispose function dispose it, like delete it, and as the count we're gonna just store the length of the index, which this is gonna be passing to the draw elements instead of draw arrays. We'll go with that in a second, but lastly we just need to dispose everything. For that, just gonna copy and paste it, because it's pretty straightforward. Like we just get whatever we stored before. In fact, I think I need to store the context, right? And right after this, I'm gonna store the context on the class, the VAO and the VBOs right here. And the EBO is gonna just be stored like this. Cool. because it's conditional on having or not an index. And whenever we want to dispose this geometry, we're just gonna get all variables and do a delete vertex array on the VAO. And for each vertex buffer object, we're just gonna iterate through them and delete their buffers. And if we happen to have an EBO because we had an index, we're just gonna delete it. So this way, just calling geometry.dispose, we can unload the GPU for all the unnecessary, if we're gonna like unmount a geometry or like change the steering or whatever. Because like VRAM is limited at the end of the day, so we want a way to actually free some VRAM whenever we need to. Cool, so that's our geometry class, pretty much like pretty robust. It will allow many class of geometries with index or not, and the way to dispose it. And the cool thing with the location thingy we are doing on our shaders, that we're not depending on the shader as long as we respect this convention on all our shaders location. And we don't need to be getting the attribute or nothing like that. So for now, I think the best thing will be to start implementing this new geometry. And for that, the first change I want to make is change this shader class into like material, because it's not really a shader. Shader is the actual vertex shader, fragment shader, and that combines like a program. And I don't want to call it program, so I'm just gonna call it material. So we're gonna go here. Let me put myself into frame a little bit. Cool. And just gonna give move shader yes to material.js. Cool. It's gonna be renaming this crap. Put the mic closer to me. Cool. And this probably we are not gonna need this anymore. So uniforms are good. And that's pretty much it. Alrighty. Now here we're just gonna do the same renaming. Material. And same deal here. Okay. This API is starting to look a lot like 3 years. Whatever. Okay. So what's next? Let me check. Yeah, first it's gonna be pretty much remove all this crap from the mesh class, since we're now just doing on the geometry, right? And what we're gonna do is actually store the geometry we get, which is gonna be an instance of a new class that we pass to the meshes. Right there on the same. It's not gonna have a PBO and it's not gonna need the contest. Scale. And of course, probably want to store the material here, so we can then from the renderer routine assign different materials to different meshes, which is something that we couldn't do before. And like this, we will be able to have different shaders or materials for different meshes, even if they share the same geometry. So this geometry, this material, and that's pretty much it, I guess, for our mesh class refactor. go to our index. Let's import our new geometry class. Geometry. And let's start creating some geometries here, even before the materials. I'm gonna need a geometry for the ground, another one for walls, and the triangle. Because if you don't remember, this is how our scene looks at the moment. It's just a plain round with two walls and two triangles. So right now it's gonna have both triangles, just the same geometry. And for that, it's gonna be doing instancing some new instances of our new class. And for this, we're just gonna have the context as the renderer context, and the actual position. We just gonna be copying it from our last ground. That's cool. And since now we got indexes, instead of repeating all these vertices, we can just do, how was it? Index, right? Right. We can just do this and do like a quad, like 0, 1, 2, and 2, 3, 0. Cool. This is the same, right? 0, 1, 2. Then it's repeated, so we can remove it. Then the 3, 1 we leave it, and the 0 is repeated, we remove it. So that way we just need the 4 vertices, and that's our quad right there. Cool. So next mess, the wall is gonna be pretty much the same deal. Let me copy in our position. It's gonna be this one. Bam. Have a quad index. And just remove the second one and the last one. Cool. And the triangle finally. Same deal. And we're gonna copy whatever geometry we had before. And since this is just a triangle, it's not gonna have any index. So that is cool that we can just draw arrays for this one, but we can just draw elements for this one. And as you will see, we will implement that independently of the geometry. Cool. So we got all geometries there, pretty much. So material, animation, and this is where the main change is gonna start happening. Which pretty much is gonna be that, I guess. I'm doing geometries round, and this is gonna be geometries walls. And it's the cool thing that now we can actually reduce those buffers. Instead of like before, we need to duplicate our geometry every time. We can just do this right now, and this will actually use the same buffer on the GPU for both, and the same for the actual triangles. So triangle and triangle. And of course we will need to define our materials, even that right now it's just the same for everyone. Just gonna do material, material for walls, and then finally our 2 animated triangles. Boom. And finally we just create the mesh as we did before, but with these new parameters and the context. We don't even need no context right now, so I guess this is pretty pointless then. We can just do it like this. Do we need the context or not? No, not. So we call them. Let's just do it like that. So groovy. Cool. So we got our mesh array right there. It's our new class. Reusable geometries. It's good for now. What else? We also need to implement now the renderer here. And for that, I know we should do the Steam class already. We definitely should. But let's just fix this so it works, and then we will do the Steam class. Since we just got one material for now, just gonna keep doing the same here, but this is not gonna be needed anymore. And this is not gonna be done because we don't got a BBO. Now we just got a VAO. And this is not necessary, and this is where the magic's gonna be happening. So pretty much we use the program, set the transform, albedo, and yeah, of course we bind for vertexAttribPointers, and we're gonna unbind it once we render, so we have our context clean. And here this is gonna be testing if we have an element buffer object, like if we pass it an index to our geometry constructor, and if not, we're gonna be doing the GL arrays as we used to, right? But if not, if we got an EBO, what we're gonna be doing is draw elements. So let me check. It's gonna be this one. Just copy everything. GL, draw elements. I'm gonna be drawing also GL triangles. The count is gonna be the actual count, which is the index count by the number of elements we're drawing. And the type right now is gonna be unsigned sort, which we're using uint16. So GL unsigned sort. What else? The offset, which is gonna be 0 pretty much, I guess. Cool. And this the geometry, yes, because now our message doesn't have the BBO or the VAO right there. It's got the reference to the geometry. And of course, we should also get the material outside, because they could have like different materials. And do this actually here. It's getting kind of ugly. Let me move the animation outside of here. First, we're gonna do just the animations. If we got any animation at all. Cool. And then we're just gonna be rendering once we animate this. And instead of doing this every time, what we're gonna do is something like this. Let me just get this. It's gonna be on animation, and then it's gonna be on rendering. I'm just gonna just reduce the message pretty much. This is what I'm doing here. I'm pretty much just uniquing all the shaders. So I'm going through all the meshes, starting with an empty array, and if the mesh shader, which this is not shader, sorry, it's this materials. Cool. Okay, so I just go through all the meshes, get their material. If the material is not on the list, I just push it to the list, and I go reducing that. And once I reduce all that, I iterate through the list of materials and just set up the common uniforms. In this case, it's gonna be the actual camera uniform with the camera transform, and that way we don't need to be doing this for every mesh, because once we start having a lot of meshes, it will start taking a lot of time. What we for sure need to do is the use program, because this could be changing through our iteration. It could be different meshes could have different programs. We should probably do here some kind of sorting, so we render all the same programs at the same time and stuff like that. But for now, we're just gonna rely on whatever the user puts as the order on the message or the scene array or whatever you wanna call it. Cool. So lastly, this is gonna be geometry VAO. So now we just do this. This is just like a hack. Will be probably removed. It's just to see that we can control our camera. Now we iterate through all our meshes on the scene, and we check if they have an animation frame. If they have, we call it, so they do their animations and shit. Then we just reduce and get a unique material list for all the meshes we want to render, and we set up the common uniforms for them. Here we will set up like the lights and all the kind of things that are common to all the shaders. And finally we do another iteration on the mesh list, but this time just setting the program and doing whatever is needed to render this mesh, which is setting this transform matrix, its albedo, should be up, I guess. And then we just get the vertex array object, and if we got an index, we just draw elements to draw that index, and if we not, we just draw the buffer as it is, and we finally bind it to null, and that's our complete frame right there. So let's check if this actually works. And that's not it. Probably right here. And this is not working, of course. length of undefined. What's going on here? No, of course we don't need that anymore. It's on all code that when we have the count here and all that, but now it just comes from the actual geometry, and the mesh only deals with whatever changes for each mesh, like the albedo. Let's put this down here. Maybe not. Albedo, geometry, and the material. Probably the albedo should be on the material, but let's just have it as well, because this, like the albedo, you want to set for this mesh, and you don't necessarily probably want to reuse the same material but with different albedos, so it uses the same shader and all that. So I think for now we're cool with this. And we can also set our position and rotation that will basically update or transform, and that's what we send every time. And of course our animation frame thingy. Oops. So let's see. Render count is 0. Nice. So that's fucked up for some reason. What is going on? Of course, we're just getting this count from the mesh, so legacy stuff, because right now, as I say, the count comes directly from the geometry class. Bam. So this is our old theme, rendered with our new, like a reusable geometry class. As you can see, the index has reduced a little bit, not too much, but a little bit. See if I did something more of camera. Yeah, one other thing I wanted to change is, because I was doing some research also, and this tilt and pitch, I think I fucked it up, because they are like the same thing as far as it looks. If I do tilt, pitch, some show tilt as this, some show pitch or tilt. It's pretty much the same thing at the end of the day. And what I see for cameras, usually what is called is tilt and yaw, I think it is, right? Or pitch and yaw. Yeah, pitch, raw, and roll. So basically always gonna be changing tilt to yaw, because that's what pretty much every person does. And to avoid confusions, just gonna have for pitch as it is, and change the heading or the tilt or direction or whatever you're gonna call it to yaw. So basically we're gonna search for tilt, send it to yaw. That's it right here, and on our index we're not even touching it, just doing the tilt. So we're golden, I guess. Okay. Something's fucked up. What did I do? I do it backwards, bro. Let me see again. It's so confusing. This is pitch or tilt? Looks like it's pitch. Pitch. Yep. So that's good. And tilt is gonna be yaw. That's it. Right. This is what I just did. So what's the deal? I didn't change it here, or what was it? I don't know. Cool. We have our yaw. How we doing on time? I don't want to do too much today. Let me see. 30 minutes. It's nice. So we're doing great, I guess, on time. Let me just check my notes, see if I had anything more that I wanted to do. No, it's pretty much the theme class, I guess. Yep. So let's do that. Let's do a theme class and start having like a proper render routine and have it all this here. So then we can just change between the themes, and the only thing we will do here is actually push meshes to that theme root or whatever. And even we could do extend from that class and create our own themes with like something that happens at construction and something that happens at disposal and all that kind of life cycle kind of deal. Cool. So let's do like a theme class, same drill as usual. The constructor. I think we're gonna do pretty much nothing. We'll probably want to receive the renderer, yes. So here we're just gonna be receiving the renderer. Mainly so we can store it and stuff. And we don't need to be passing it around because we only want to have one thing at a time, I guess. So we can change that on the future and just pass the renderer to the animate and render functions. But for now, I'm just gonna store it here, so I don't need to be calling it no more. We also want to have like a root, which is gonna be pretty much the same that it was our meshes hacky thingy here, like an array of meshes. Right now we are not even gonna support children's. It's all gonna be on one level, on the root level, but on the future we could probably have a dot children on the meshes and reconstruct their wall matrix. For that we also will need to have wall matrices separated from the local matrix, so we can reconstruct the tree and all that. So for now it's gonna be one level. No children for me or for this program. Renderer, camera, and yeah, that's pretty much it for a constructor, I guess. And I like to separate the animation from the rendering, even that probably could happen at the same time, but just to be polite, let's do all the animations first and then the renders. For that, let me put this a little bit up. Let me change it, in fact. This is a good one.
Imagine yourself young, with pockets full of water. Haven't learned to hesitate yet.
My baby.
Sun beats down all on your skinny neck as we kick around the shore. You know the rest.
There you go.
Imagine yourself dumb, like someone's careless daughter. You can't remember just what he said, but it still bears down.
in time. Let's do this. Alright. So I'm gonna get our context probably. That's not the render. Not really. So at the end of the day, what we want to do is pretty much what we do right here. This is gonna be the roots. That's what we're gonna be needing. Alrighty. And on this one, we're probably gonna receive that. The delta and the time from the renderer. This probably will be running from here instead of this hack that we have right now. This will have the string and we'll just call those functions, I guess. So that's our animation routine, pretty much. And for the render, what we want to do is this too, I guess, that we just wrote.
I used to know this boredom potentially asleep, and I can't feel the rain till it cuts across my cheek. But I must get paid.
We're gonna need the context, so that's why we save the renderer here.
Let me write this down before I
Just gonna get it right there. Boom. What else? Probably we want to do the clearing of the screen right here instead of on the renderer. Just put it right here, right before rendering. Manias. And of course we also need the camera transform. Just get it from the renderer. Like I say, maybe we wanna do the scene independent from the renderer. We can probably just pass here the context and the camera. But fuck that for now, I guess. Alrighty. So I guess we got our scenes, pretty much all that we need. So let's have this dual render again. For now, we're just gonna have one scene. Once we do some kind of router or something, we will probably not have a scene at the beginning and just have like an update scene routine that disposes the current scene and put a new one. So once we change the URL, we could have different scenes and all that. But for now, let's just test this and see if we can do this. Right after the camera, I guess. This is thin, new scene, and we're gonna pass the renderer, right? Renderer, which is gonna be pretty much this. Cool. And then our animation tick. It's not gonna be doing that. And it's just gonna go get the steam, I guess, first. Just remove this, remove this. Need it. Just the last tick and the steam, of course. So that way. Here we just call steam animate with the delta and the time, and probably later we can even do like a different loop for this one, so they're like on a more fixed time rate kind of thingy, and let the renderer be on the vertical sync on the monitor and all that. But maybe we want to run our physics or whatever animations at 30 fixed frame rate, 30 FPS or whatever. So I think it's cool we have it separated. And finally we just call the render, and we don't need to pass nothing, right? Because that's all right here. Yeah. So that's pretty much this. Remove this sooner than later. I need to do a cube or something cool. So what's left then? Start using it that. And of course remove all this. I already did the on animation frame thingy, right? And also remove it from here. And we don't need to do this anymore. Yep. Just gonna store this somewhere because I want to keep doing this. So I need to extend the steam to do that. Okay, let's comment this. This will work, but I have no measures. And we just need to push this to our root. I think we're golden.
Hold it! Now we're downtown at the show. Now we got no place to
Fuck.
go. Won't you read to
Let me
me
go
when
back
we
to
get home?
the
Hold it!
whole
Lay
thing
your
here.
by my bedside. Think
Yes.
back, alcohol with the little bite in the shakes. What do you want me to say?
this. It's gonna do a for each.
Everybody's telling me that. Everybody's telling me that I got to change.
And this is gonna be a for each then. And push it to the actual
How the hell
steam.
to get so thin? How to get the shape I'm in when I eat and I fight and I still feel small.
Mess.
Stop 'cause I can't say what's good for us all the time anyway. And when you work in the dark all day, there's no time to wait until it goes away. Everybody's telling me that. Everybody's telling me that. Everybody's telling me that I got to change. Change.
So we have a scene class 2. Our index is getting pretty much non-existent. I just need a way to put this on the scene. And for that I think we're just gonna be extending the scene class for each different scene we want. So it's gonna be creating a new folder here. Scenes. First level 101 classic, and it's gonna be importing for the scene class. This is where add symbol comes handy. From Bing. And then it's gonna create a class. Another one. It's gonna extend. Right here, it's gonna be doing this. Cool. And I'm just gonna be getting the camera. Boom, boom. But we should probably start doing some kind of shader getter on the camera, so we need to be remember all this bullshit. But at the same time I like it because the user decides when to update the vectors and there's no like redundancy. We do like a getter shader. It's hard to not do some redundant updates at the end of the day. So for now I think it's gonna leave that responsibility to the user, but that's probably gonna get a bunch of bugs, so people are gonna be forgetting to update those vectors every time they change the position and shit like that. So I don't know what to do with that. But let's continue. What we also want to do is override the animation methods of this thing, like so. Same deal. Let's call the super method first. Cool. And finally, just do whatever we were doing here. Cool.
Say something stupid, like it's okay. What you say in place inside, sort of silk from which I see you every day.
Cool. So we got that there. It's cool. Then it's gonna be moving all of this thing. Cool. These ones. That's all of them. Constructed. In fact, once we run this should be already on this. So let's just get it from there. So we can do it all from the same scope. Cool. Shift. We can probably do this at the top. So first we set up our camera for the stream. We create some geometries. Just get the context right here. Oh. Roto. Spice it like that. Cool. Just gonna get that quad class. Animation. And like we did before, we just create our meshes with that geometries. That's pretty much it. We need to do some disposing if we want to change the style, but for now it's gonna be just hard-coded on the index, since we don't got no router or nothing to change between them for now. Let's put this a little bit closer, like that. So I barely hit the levels of the music. Alrighty. put it a bit up here. Testing sibilance. Alrighty, so I think we're golden. Our scenes will be ready, and we can remove all the other crap from that index. But let me just do this first. We're gonna go to renderer and remove this. Here it's going to be doing this if we actually have a steel. Boom. Golden. Like I said, we will need some kind of routines to dispose and reset the steam if we want to be swapping it. But for now it's going to be receiving it on the constructor and setting up right here. But it's already gonna be fine. Still it. No more ifs are necessary. Cool, so we need to pass this in here. It's gonna be all level 1 thingy. New level 1. There you go. But we actually need. So yeah, just gonna do it right after. Thin. New level. Oh shit. Level 1. It's a bit retarded, but who knows? Just do it like that. I will make it better later. Yeah, this is pretty much regardless. Anyways, we'll remove all of this now. Here. And yes, I think we're just gonna be doing that. It's gonna be not still need the camera and GoPro. Let me just do this for now. It's gonna be passing the actual class. Boom. In fact, we should be able just to pass it right here, right? Level 1. Cool. And it's gonna be complaining, of course. Let's do this then, because then that's what the router is gonna call once we implement a router. So yes, shut steam. I know why I always say we as I do it all the time. Whatever. Makes me feel less alone, I guess. Steam. No, render doesn't work.
Neighbors and cops in my head, they drag me out of my bed with all the things that they said I know. Why? 'Cause they tried. I know they tried.
What? Property, animate. Where's my fucking thing then? Of course. I thought I didn't remove this, but paying more attention. Cool. So we got our scene right there. Let me see if we can do a quick steam to test.
Shut up!
It's gonna be with the same shader and all shit, but much more simple. You're just gonna have a ground and a triangle. We should probably start doing classes of this, so we can just call new grounds, geometry or whatever.
It's
But for
all
now,
a part of
like I say,
she
just
said.
keep it
That's
simple.
just the way it is. Sometimes you stay inside. Here comes my ride, she said. Here comes my ride. On the table or on the floor, where she turned to leave an ash.
Okay,
saw
now
some
we're gonna do
pennies by
any
the
custom
door.
animations for this one.
Made me
This
think
is
to
gonna
get
be the
some
constructor.
cash. Today or
That's
tomorrow,
the way we're gonna do like
leave her
multiple
alone.
streams and shit.
Leave her alone.
And for now, the other way we can file any text
Here
with
comes my
index.
ride, she said.
Then it's like the one we did
Here
here.
comes my ride.
That way we can just do this. Cool. Ah, shit. There we go. Let me just do a quick thingy here. And so I can just do this, this. And probably we want our default camera position to be just a little bit up. While you stop. Values 0. Oh. So 1.5. It's like the eyesight, more or less. So probably we can remove this from here. We don't care.
Within the influence of innocence, we were dressed to kill, pulling styles from the atmosphere,
swap this.
Possible to fail.
It doesn't work.
Like the dim lights on the dash.
Of course. Also need to swap these
We were
ones.
pulling out
Boom.
of anywhere.
In fact, we can just leave this because the leader is gonna be complaining.
And I can tell by the way the rain hits the glass
Level 1. Just do
that
this.
it wants to be cold. It wants to be
Level 2.
snow. Is it falling there? Skewering small
One.
fire.
Boom. Cool.
Contain another shining front page spread where old worn men conspire.
So time.
So
I
much.
wanna be doing 2 minutes
Saturday,
time.
other
I think
day,
I'm gonna cut it right here.
lives are at stake.
Think about how to do the router
God
for
forgive
next
us
episode.
for the hatred.
Just comment this out. I'm gonna commit it like that.
Boys forget.
So we are 1 hour in already.
Both coast. Oh, what would it take to get out now?
So yeah. Yes, because if I do the router, it's gonna be quick, probably. But I'm gonna be needing to do all the disposing of this thing. And that will complicate, I guess. I don't really know how to do that right now. Let's do another shader for the ground. Let's get this shader. There we go. It's gonna be this one. This is not a vertex very much on wall space.
Is this what they call the end? Are we sleeping on a dark star? Is this some saint we all
So
forgot?
yeah, just copy that.
Is she burning in a parked car? This violence is so slow.
Frag. And grid
Patience will
over.
do us in.
It's gonna be pretty much the same deal,
So mothers, stop looking for your
but that
sons
is
in the
gonna be
woods,
having an out.
'cause you will find them on CNN. It's
Deck
when you
3
try,
gonna be frag boss,
but you can't evict the
position,
sun.
whatever.
Lights up
boss.
1 hour every morning, every day. You know you are the one.
Nah, frag position.
So much. Saturday,
There's for free.
other day. Lives are
Frag
at stake.
position. Then it's gonna be
God
equals
forgive us
to pretty much
for the hatred,
this.
for the risks that we take. Boys forget promises.
First, we're just gonna do a
Both
back for
What would it take?
position.
Forget promises. Both coasts.
Frag position is gonna be a deck 3 of that. And it's gonna be the same but multiplied by the camera. Cool. So then here we're gonna get like a name. Flag position. And this is our deal. Just gonna compute that. Okay, so let's do that. Chord, flag position, XT. Boom, 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 boom.
much more can we stand to say before clouds complain?
Focus.
Soak to that
Mix.
critical state with the
Albedo.
overdressed words.
And the actual with color.
And how much will the leitmotif sway to compensate
It's gonna be
for fallow yet vigorous play on the century's tape?
1.0
On the
is
limp
that.
but yet name.
Cool.
Hold out,
Leaves a great shader,
hold out,
I think.
because this moon is twice as good.
Just included to the index.
If you see through a year of night, what you thought you understood. Set out,
Boom.
set out, because
And
this
on
haze
the
is
level
bound to
1,
wane.
maybe level 2, so we change it a bit.
Can no longer pretend
Just
to
gonna
hide.
getting those 2 new
Will it third
sailors.
class seats on tomorrow's train?
Standard material, that's what standard is written, right? Spell, yep, I guess. And some grid material, cool. Running out of coffee. Cool, let's check this out. Slow second level. Let's just put a line here so it doesn't complain.
Made lies true. Say anything and I would believe you. There were demons, maybe more than a few. So what could we do? 'Cause in my life there was only asbestos. Raymond Williams, you always took the best one. Now like failed pedestrian dreams. It's how it seems to me.
Guess I need to do a block.
Once again back out on the highway. Watch the traffic, you know it's a Friday. All the seatbelts and all that. Change your plan.
Sorry,
You can get by
like vibing.
on a few cents. You can try to make a horse win once. You can't put back together what you
That's vibing going on. material before. And that threw me off base. Now we're there. Cool. Nice clip. First try. Nice. I'm getting better at this shit. Only 40 minutes. Let me check. If I can just do the same here. Just pretty much copy it down. I don't know why I did it here. I really want it on the other level, but whatever. Let's just do both. In fact, we can probably do the same as we do with the geometries. I have materials, object, just like that. Cool. Standard. Maybe I should change it to basic. This is like much more short. Who knows? I like standard. None of my shaders are fucking basic, you know. This is the standard.
Rain comes down, turns your shine back to right. Yeah, does that mean you have to sever up? Someday she will come round, reverse the earth, turn your friend back to dust. Let you hold on to something forever. Hold on to something forever. Hold on to something forever. Forever.
I guess it works. We just need some fog and stuff. We should probably limit not lighting, but at least some fog next time. Probably we need to start using something like GLSify, like this, like GLSify, so we can like have imports on our shaders and all that. With this you can just do requires and all that, pretty much. What was it? Shader,
Run like hell. Remember there is history.
webpack,
They don't believe you. Send them back to me. They can't deny.
shader,
You just have to.
loader, cool a bit.
Roots and ruins are the same thing. They
Ah,
are
no,
the
there you
same thing.
GLSify loader. GLSify, or whatever you pronounce this loader. And with this, then you can just configure it on Webpack, and then on your shaders.
The new poetry.
First you can import it as the same as we're doing right now with the raw loader,
When I know
but
you're
it also
like Automo's the tree.
allows you to do
Still strong. The ruins of the same sea.
some
Look out
samples
for
pro.
God. Look out for girls. And other stories that could tear apart our world. No matter what.
I don't know, but I can show you
No matter what
you can do imports and stuff, trust me, so that way you can have like a fork file and then import that fork logic or function on all of your other shaders, and it will just be like a constant there, instead of needing to copy and paste all your lighting and stuff on every shader. So cool. Maybe if I just do that, it's kind of quick. No, fuck that. Well, it's 120. I think we can afford it. Let's try.
Look out for guns, look out for girls, and other stories that could tear apart our world. No matter what, no matter what you do, I will look out for you.
Okay, so jar add. Stop. Yeah, it's gonna do this as a tab dependency. Cool. So, what was it? That's pretty much it. Then we're also gonna include this extension for our imports, libraries.
If we are nature's detour,
Yeah, pretty much that one. So we'll route first through our DLC file loader and then through the
you
raw loader
are number
as
6.
it did before. So this will pretty
Just
much
neglected
don't broke
by these
anything.
With all the confusion around, hey, schedules
guess.
at possibilities under solar system simulation. A hesitation's elegy. These are the last days that we will spend in this room. Another temporary shell to help me protect you on any ordinary night. Sip would last a
Let me
song,
check, 'cause I'm pretty sure I used this before, bro.
but tonight you're up on your way out the door. Half as long.
The lighting, what is this lighting applied to? There you go, just to import them. Alright. Let me test this. Just to precision ESL this slash precision. Let's just try that. Precision, just gonna have these 3 lines. Probably to restart Webpack also. Precision. partition. Any partition, there you go. So this hasn't worked. Maybe that wasn't the actual, and it's not GLSify, and I fucking misremembered it. It seems that I was using some other ones. Let's just check that, because I like this thing much better. I think this is pretty old, it looks like. This is all what I need. I think it's gonna go with this one. Let's go with the modern thing, Dios. Trust me. So, how the fuck we import them? Kind of retarded. But who knows? Just look at it on the future. But yeah, that's probably the one that we want to use. It's just not as simple as I imagine. It's more for like having functions and stuff, not direct text imports like the other one I used to use. So let's go. Back and just commit this and call it a day. Cool. Let me see if everything works. Looks like it. It's too fucking bright. Should be like a uniform, I guess, too. Hey. Let's go in the middle. That just so it's not so fucking bright. I guess because it will depend on the background also. So who cares? We got anti-alias, right? Is anti-alias or anti-aliasing? Let me check. Need not what you need. Can unlearn. It's anti-alias. Try to unlearn. I guess it's there. Evidence heals this case or what? Just give me something that I can. So that's for today. I guess it's gonna commit this. Do a quick recap maybe. Oh, we're golden here. Yep. Git commit. E03. Let's push it. Okay, so basically have now a web page, live reload, independent geometry class, reusable, with buffers and disposable, a camera that we can control the yaw and pitch with the Eulers and disposition, and a shader class, material, whatever you want to call it, that compiles our shaders, and a mesh class that allows to set up all the things together, like the geometry and the material, and put some transformations and paint some things. And on top of that, we got our Steam class, new, that is extendable, and you can do even extend their animations as we do here. And we're rendering some camera, whatever, change it. And we got multiple streams too, and we will need to have a way to actually swap in between those streams, but that will be for the next episode. For now you can just uncomment, swap the comments, and you will see it loads the new stream or it loads the old one. So we call them, everything's on the repository. I will just tag it right now and upload a new screenshot and all that goodness. But if you just check out master right now, that will be the thing, and it will be with a tag like all the other episodes. So that's it. Thanks for watching, and see you around.